Hello, this is Chad here, and today we're going to be looking at the Arduino Uno, which is based upon the Atmel 3208 microprocessor. Arduino itself is an open source software and hardware development platform that has voltage, analog, and digital pins that can be tailored to your project's needs. It also has an optional power input as well as a USB connector. In this project, we're going to look at how to connect it to Ubuntu. I purchased this one from this particular Arduino Uno from SparkFun.com.
Alright, with the computer up and running and the Arduino Uno hooked up to the USB port, let's install the necessary software. Go to the Ubuntu Software Center. Under the search bar, type Arduino. In here, since my software is already installed, it says to remove it. However, yours being not installed will have the install option. Go ahead and click that button. While it's installing, scroll on down and notice some of the user's comment. Particularly, I find this one interesting. It's open source software and it's open source hardware. Once it's finished installing, close it. Go to your applications menu. Under there, developer tools. You will find the IDE installed. Click on that. To configure your IDE, click on Tools, choose the board, in my case Arduino Uno, and the communication, which will be, in my case, serial over USB. Below this video you should find some code. Go ahead and copy that code and paste it on in to this section. Now with the code pasted in, let's go through the three main sections of code. First, in the global variable declaration section, we have an integer pin set to the value 13. This constant represents the digital pin labeled 13 on the Arduino board. Second, in the second section of code, we have the setup function. This function is only called once upon startup, so it contains all the initial instructions that will configure the initial state of the Arduino board. In our case, we instruct the microcontroller to configure digital pin 13 to be an output pin. In the third section of code, we have the loop function. This function is called immediately after the setup function, and it contains all the necessary instructions to perform the desired runtime task. This function has a particular behavior in that if the function ever returns, it will be immediately called again. Our desired runtime task will be to create a square wave. After all, we are using a digital output pin. A square wave is a kind of non-sinusoidal waveform which are universally encountered in digital switching circuits and are naturally generated by binary logic devices. In this square wave, we are alternating between approximately 0 volts and some positive voltage. Since our Arduino Uno is hooked up to the USB port, we'll also be using 5 volts. Take a moment to familiarize yourself with this diagram. Amplitude, pulse width, rising edge or leading edge, falling edge or trailing edge, one cycle or one period. Now, let's go back and see how to implement a square wave in code. In the loop function, we first initialize the state variable to be 0. This variable will keep track of what the next voltage step should be. Next, we enter an infinite while loop, thus preventing the function from ever returning. The conditional logic is fairly simple. If the next step should be low, then instruct the AT microcontroller to set digital pin 13 to low and set the state accordingly. Otherwise, we need to set voltage to high. Last, we instruct a 2000 millisecond delay, or 2 seconds. Now, in our mind, let's paint a picture of a square wave diagram with this code. We are operating between two voltage levels, low and high. The difference between these two will give us the amplitude. The pulse width between each voltage step will be 2000 milliseconds. The rising or leading edge immediately occurs here when we set the voltage from low to high. The trailing or falling edge occurs immediately here when we set the voltage from high to low. Each cycle or period in this wave is 4000 milliseconds because we have to go through the loop twice to get both a high and low voltage step. Now, let's compile this project. Click Sketch, Compile. Notice the it compiled successfully in the resulting binary file. Now, let's upload this file to the Arduino Uno by clicking Upload.
With the program running, let's see what effect it has on the Arduino board. Let's do this by setting voltage to DC, connecting the negative and positive pins, and watching what happens on the multimeter. So we have 5 volts, 0 volt, 5 volt, 0 volt, and etc. on and on.
Now, let's change the pulse width to be 1000 milliseconds for a total cycle of 2000 milliseconds. Here, we'll upload the code.
With the 1 second delay, let's look what happens. 0, 5, 0, 5, 0, 5, etc.
Now, let's set it to have a 0 millisecond delay, or that is, no delay at all. What will happen when we upload this code to the board?
So I have a question for you. Now that the program is running on the Arduino board with 0 second delay in the loop, what would happen if I measure the voltage right here? What would the multimeter say? That is, right now the Arduino board is setting voltage to high, to low, to high, to low, high to low, as fast as it can. What would be the reading on this multimeter?